Hi, it's Mark. I thought in this video we could talk a little bit about models that help us visualize point charges. So we'll start with an unboxing of the electrino and positrino models, my favorite ones, my decorative ones. This is something I got on Amazon. I have no affiliation with them. It's called Titiscan Crystal. I don't remember how much these were, but let me unbox them. All right, so here is the electrino model. It's a blue sphere. I don't know if you can see that very well. Is it shining in the light, maybe? And this is what we're going to use. One of the ideas for a point charge is we could use just a blue sphere for the negative point charge. This is the standard color for negative in electronics is blue. And so it's just a sphere. Now, in actuality, point charges don't have a physical size. They have a radius of 0, and they exist. It's just a point from which negative potential flows spherically at a constant rate. So this is the electrino, and let's see if I can get this out of here. These come with a nice little stand, so you can put them up like that, and keep them on your desk or something. Once you're into this new ontology of point charge universe. The other one I have is a red one. Red is the standard color for positive. So we have, again, it's modeled spherically because that's how the potential emerges, even though, just like the electrino, this has no physical size, radius is 0. So when we model it as a sphere, we're really looking at the potential coming off of the point charge at a certain point in time, because the potential emitted, like right now, will travel in a sphere with no insides to this point, and then it'll just keep getting bigger, bigger, bigger. Okay, so we've got electrino, we've got positrino. If you really get into how nature works, you might want to get a set. Now, for everyday use of illustration, I just use racket balls, red and blue racket balls. These are made by Penn. Again, I got them on Amazon. I think they're like $10 a can or something. But these are nice because, if you drop them, they're not going to break or scratch or anything. And again, we have the blue electrino and the red positrino. So we've got positrino, electrino. Now I like to use this size. It's easy to hold in your hand. Also, one thing to keep in mind is that this new ontology of nature and the universe is so easy to understand that people might be inclined to start teaching it to young children. So I would not recommend using red and blue marbles or anything small that a young child might want to put in their mouth and accidentally swallow. So I think these are pretty safe racket balls, and they bounce off of each other if you drop them, no problem. And you can get as many as you want. If you wanted to have a full set to build all the fermions, you'd need 9 of each, to build all of them in combination. It turns out we only need 12 of these per fermion, but the Noether core, which I talked about last time, our triple binary nucleus of the fermions, has 3 of each. And so then you have the 6 personality charges that surround the triple binary Noether core. So if you had 3 of each of these, you'd have 3 red and 3 blue. And then if you had an electron, you'd have 6 blue personality charges around that nucleus at some distance. So 3 red, 3 blue, plus 6 more blue, you're going to need 9 blues to make an electron, and 3 reds. And likewise, if you were making a positron, you'd need 9 red positive point charge models and 3 blue in the nucleus with the other 3. So this is what I like to use. Last time I was talking a lot about how point charges rotate around each other. They spin. It's tough to do this with your hands topologically, but if I do it this way, I can do it like this. So you can see that they would spin around each other. Now, the reason they spin around each other is because opposite point charges want to come together, and they want to pull together like two magnets. They want to pull together. If you had the same point charge, like two positrinos, if they got close to each other, they'd want to push apart. They don't want to get anywhere close to each other. They really want to push apart. It takes a lot of energy to push these together. Whereas for a red and a blue, they really want to be together, so it takes a lot of energy to pull them apart. So, these concepts of how particles attract or repel are things that can be taught at a young age. And they're very useful to understand how things work. So, so basically what's happening in nature is at the very highest energy, you've got these maybe you have these individual point charges flying around, and when they go flying past each other, they can capture each other. Just like, in a solar system, the gravity captures, the planets, and on the Earth, the gravity captures the moon. And then if you look at the whole solar system, there's, asteroids around us. Gravity is capturing anything, but gravity is a higher level concept. We're working at the lowest level now, where there is no gravity yet. We're going to get there, but what you have is these point charges that pull together, and then when they pass, they want to rotate. Now, if they were super high energy, they could pass really close and then form a really tight circle around each other. But if they were lower energy, passing each other, then the circle they form would be bigger, right? Or if they start small and with high energy and they run into collisions, they can pass energy off, and the radius can grow over time. As they give away energy, that this circular orbit, the radius of that orbit could grow. So I think that's all important. I just wanted you to understand another way to visualize. So when you're thinking about point charges in your mind, if it's helpful, you can think about the positive as a red little sphere and the negative as a blue sphere, the electrino, the positrino. But just remember, point charges do not have a physical size. So this is a model of a point charge that has emitted potential, and that potential has reached this surface of the. So there you have it. Those are your models, and hopefully that's useful to you.